Take a look at two popular coding systems, the 3 and 4 digit system and the EIA 96 system. Let's take an example of a 3-digit code. The first 2 digits represent the significant values of the resistance. The third digit represents a power of 10 multiply factor. The resistance value is therefore 31 times 10 to the power of 2, which leads to 3100 ohms. Now we consider a 4-digit code. Here the first 3 digits represent the significant values of the resistance. This code is used for more accurate resistors. The 4th digit is the multiply factor. For this example, the resistance is 792 times 10 to the power of 0, which results in 792 ohms. Now we will solve 4 examples which are a bit different. The first one has only a 0 and represents a so-called 0 ohm resistor with no resistance. This resistor has the letter R as first digit. The R represents a decimal, so this resistor has a value of 0.382 ohms. The third example has the R, or decimal, between the 2 and the 3, which means a value of 2.3 ohms. Due to space constraints, sometimes the numbers are underlined instead of using an R. So this resistor has a value of 0.068 ohms. Remember that often is deviated from these systems, therefore it's always a good practice to check the manufacturer's datasheet. Now we take a look at another popular coding method, the EIA 96 system. This system is based on the E96 series of preferred values, so these resistors should have an accuracy of 1%. The first 2 digits represent a code that is used with a table to find the resistance value with 3 digits. The third number also represents a code to retrieve the multiply factor. Let's solve this particular example. By looking up 38 in table 1, we find a value of 243. In table 2, we find that the letter C means a multiply factor of 100. This resistor has therefore a value of 24.3 kilo ohms.